everyone. So I'm gonna do two examples with you guys in order to practice the substitution method of solving a system of equations. So we're gonna do two examples. If we take a look at this first example, the first equation is y equals negative 3x plus 5, and the second equation is 5x minus 4y equals to negative 3. So the first thing you always want to think of is which variable is isolated. Okay, that's the first thing. Meaning by itself. So if I take a look, I notice that in the first equation, y is by itself. Y is equal to negative 3x plus 5. So since y is equivalent to negative 3x plus 5, I can take negative 3x plus 5 and substitute it for y in the other equation. And it's going to look like this. So I'm going to take 5x minus 4, and instead of y, I am swapping it with its equivalent expression. So I'm going to put that in parentheses. So that is negative 3x plus 5 equals to negative 3. Okay, so now you can see that the whole equation is in terms of x. So we can solve for x. So I just want to write that second step was to substitute the equivalent expression into the other equation. Okay, which is what we did. We substituted negative 3x plus 5 in for y in the other equation. Now let's start to solve this. First, we have this negative 4 in front of the parentheses, so that tells you want to use the distributive property. Okay, so I'm going to bring down the 5x. Negative 4 times negative 3x is positive 12x. Negative 4 times positive 5 is negative 20, equals to negative 3. Next, you are going to combine your like terms. Okay, they're on the same side, so you just add them. 5x plus 12x is 17x. Then I bring down everything else. So now we're working to get everything away from x. We're solving for that value. So I'm going to add 20 on both sides. I'm going to bring down the 17x. Negative 20 plus 20 is 0. And negative 3 plus 20 is 17. Lastly, we just need to divide by 17 on both sides. X equals to 1. Now, we have our x value, but we're still missing the y value, because remember, we're algebraically determining the solution. Okay, so you can choose either equation to substitute one. Now, if I look at both equations, in my mind, the first one's going to be easier. So I'm going to rewrite the first equation. And I am going to substitute 1 for x. So negative 3. Anytime you replace a variable, it's always nice to put parentheses. It makes things easier. Plus 5. And -3 times 1 is -3 plus 5, and so y equals 2. So the solution, the point of intersection of these two lines, is 1, 2. Oops. So these two lines intersect at this point. Now let's take a look at one more. Okay. As you could see in this example, we want to think about the same steps. Both of these lines are in standard form, okay? So we don't have a variable that is by itself. Okay, so if we go back to the original notes here, I'm just going to copy this so I can bring it over here. It's not pasting, is it? Hold on. Okay, it pasted. What happened here? Okay, sorry about that. So the thing that we want to look for is to ask ourselves which variable is isolated, okay? And in this case, we don't have one that's by itself. Therefore, we're going to have to change things around on our own. So what you're going to think to yourself is, okay, which equation can I easily manipulate so that one of these variables, x or y, is by itself? Now, if I look at the second equation, x minus 2y equals 11, there's a way for me to get this x by itself. I can easily add 2y to both sides so that x is alone. So I'm going to add 2y to both sides, okay? And now I rearrange the second equation so now that x is by itself. So now we have x equals to 11 plus 2y. And the top equation stays the same. We need one of the variables to be by itself so we can continue with the substitution method. So now at this point, I can say, okay, I have x by itself. I know x is equivalent to 11 plus 2y. So I'm going to take 11 plus 2y and replace and substitute it for x in that equation. So this is what it's going to look like. I'm going to have -7. X, we are replacing with 11 plus 2y. So I'm going to leave that as open parentheses and rewrite everything else. Okay. At this point, the whole equation is now in terms of y. So we can solve for y first, which is different from the past few examples we've been looking at. So first, when we always have a number in front of the parentheses, it tells us to do the distributive property. So -7 times 11 is -77. -7 times 2y is -14y. And then we just write everything else out. It's -13. Okay. Now at this point, we're going to combine our like terms. They're on the same side. So 14y minus 2y becomes negative 16y. So we have negative 77 minus 16y equals to negative 13. Okay, now think about what we should do next. We are going to add the 77 to both sides. We're looking to get y by itself. That's what we're solving for. So what is 77? Negative 13 plus 77. 64. So I'm going to bring down the negative 16y equals to 64. And lastly, divide by negative 16. And we get 4. Negative 4, sorry. Okay, now that we have negative 4, we have our y value of our solution. We need our x, right? So let's, again, substitute into any equation. I'm going to use the one that we manipulated here. I'm going to use x equals to 11 plus 2y. Pretty simple to substitute that y value. So we have x equals to 11 plus 2, and we know y is negative 4. So what does this evaluate to? So we multiply first. 2 times negative 4 is negative 8. And 11 minus 8 equals to 3. Okay, so our intersection point, our solution of these two lines is 3 comma negative 4. That is our solution. Okay, I hope this video was helpful. We're going to continue with the next method we're going to learn in class, which is called elimination. See you guys soon.